Hello friends, welcome to another lecture on respiratory physiology. It's very short but important lecture of respiratory physiology. So it's about lung capacities and volumes. When you listen about spirometry and pulmonary function test, these are what tests to determine lung volumes and capacities. Why it is needed? Actually, there are multiple pulmonary diseases like obstructive diseases are there. Obstructive diseases means difficult to inhale. Then there are restrictive lung diseases are there, that means difficult to the obstructive means difficult to exhale. Restrictive diseases means difficulty to inhale, there is difficulty to inhale. As well, there are some mechanical problems like pressure diseases are there, like nerves are not working well, when nervous system is causing this respiratory movement to hamper. Okay, some neuronal diseases or some nerve problems are there, like you will come to know about myopathies and the other problems. Okay, so these are mechanical or pressure related problem. Myopathies mean muscle problem, ribs problem, neurons problem, diaphragm, some disease of diaphragm. So these all causes what, these volumes not to deliver properly. Okay, we inhale some air and we exhale some air in respiration. We know our ribs and muscles expand, our diaphragm contract and become flattened, so that expansion takes place, and we inhale some amount of air as well. This contraction of chest is what passively done. Okay, it is passive process, so this contraction is done passively. So we inhale some air due to expansion and creation of negative intrathoracic pressure, and we exhale some air. But what amount of air we inhale, what amount of air we exhale, and what amount of air lung itself has. Okay, so this is what we call lung volumes. Okay, and lung capacities. Actually, these two terms, capacities and volumes, are different. Volumes can be measured. Okay, volumes can be measured, capacities can never be measured. Okay, so the measured values, when added these measured values, we get capacities. When we add the measured values, we get capacities. At present, we have to understand what are the lung volumes. Means firstly we will consider lung volume because they are measurable, and then we'll go to lung capacities from lung volumes. Okay, so let's put a graph now. Say this is graph. This vertical axis is for volume. You can say this is volume in ml per kg. Let's talk in ml per kg because different person can have different body weights, so the volumes depends on body weight. So let's discuss here in ml per kg. Okay, so I'll plot some figures here. It is 0 here, it is 15 here, it is about 30 here, and it is about 37 somewhere here, and it is right about 80 here. Fine, so these are some figures that I am going to plot here now. So this is volume for ml per kg in ml per kg. Fine, now with time, what are the volumes? This is time, say this is time. Okay, this part, in this part, that is between 30 and 37, I am drawing the normal respiratory cycle here. Okay, the normal respiratory cycle is of inhalation and exhalation. What is normal respiratory cycle? It is of inhalation and exhalation. I'll use different color now. Say in normal inhalation, this is what inhalation, I am inhaling some amount of air, and here I have inhaled this air inside. Now I am exhaling the similar amount out. The similar amount of air will be exhaled out. The amount of air I have inhaled, the similar amount of air I am exhaling out. Fine. So this activity or this volume of inhalation and exhalation, the activity of inhalation and exhalation in normal breathing. Normal breathing means what? Which is not done with the conscious efforts. like I'm talking to you and I'm breathing too, but I am not aware of my breathing. As well, you are not aware of your breathing now. So at this point, we are breathing normally. It is quiet breathing, not done forcibly or consciously. So the breathing which is not done consciously or forcibly, that is normal breathing, where we inhale some amount and exhale equal amount of air, is called which volume? This volume which is inhaled and exhaled in normal quiet breathing, that is not done forcibly, is called tidal volume. This is called tidal volume. Tidal volume means denoted by TV or VT. You can denote it by VT. This is V volume and this is T. This is tidal volume. So what is the value of tidal volume from this graph? It is in between 30 to 37, means 7 ml per kg. 7 ml per kg is tidal volume. Okay, 37 minus 30 is 7 ml. So whenever we talk of standard values in medical field, we talk of a standard value for adult, standard adult weight. A standard adult weight is always considered 70 kg. A standard adult weight is always considered 70 kg. If it is 7 ml per kg, then what is for 70 kg? It will be 70 into 7, that around say 4900 or 5000 ml or 5 liter. It comes around what? 5 liter, that is 500 ml. So normal tidal volume is what? 5 liter. Is 5 liter, 500 ml. For what? For 70 kg adult. And these all values will be for 70 kg adult. 70 kg adult. Okay. So now again the inspiration, again the expiration. This cycle continues in quiet breathings. Is it clear? The cycle is continuing in quiet breathing, and every time I'm inhaling, a 70 kg adult is inhaling what? 500 ml of air and exhaling 500 of air. Inhaling 500 ml, exhaling 500 ml. Is it clear? That is tidal volume. That is the volume of air inhaled and exhaled in a normal breath or quiet breath, which is done without conscious effort. Okay, fine. Now if here, say here, I have inhaled this air normally 500 ml, but stop here. Not I am expiring the similar amount of air now. Now I have just inhaled the air, and say after inhaling this 500 ml, that is normal breathing, normal inspiration, I am inspiring forcibly like this. Now I am inspiring normally. Now I am inspiring to more extent, that is forcibly to full extent. Then this graph will raise to this level. Okay, this is full capacity, full inspiratory capacity. After normal inspiration, if I am inspiring forcibly to full extent of my capacity like this, without expiration, I am just inspiring normally up to tidal volume, and then I am inspiring to full capacity. So that means here this is something, some new value is created here. Okay, and then I will release the similar amount here because I have inhaled that much amount. Fine. So this value, the value here, this value is called inspiratory residual reserve volume. This is what? IRV, inspiratory reserve volume. And what the value of this? It is in between 37 and 80. That means the value is about 43. It is 43 ml per kg. The volume is in ml per kg. So this difference is 43 ml per kg. 43 into 70. What does the value comes for? 3 liter. It comes about 3 liter. About 3 liter. I am not that good in math, but round figures can work. Okay. So inspiratory reserve volume, is what? This was 500 ml. Now this is 3 liter. Is it clear? So inspiratory reserve volume is 3 liter. Now, so this is called IRV or inspiratory reserve volume. Now, say here I am breathing again normally. Say here I am breathing normally again, and now Now after inspiration I have expired the similar amount but stop here like this. This is normal breathing. Took 500, expelled 500. But even after expiring this normal amount, if I go on expiring further like this, if I go on expiring further like this, then this values, this expiration will continue here. This expiration will continue here. Up to this value, this expiration will continue. And this will again have to inspire the equal amount of air, isn't it? So the extra, this is additional amount of air which is getting expired. Besides this normal expiration, this additional amount. Similar here, what was additional amount of air which was getting inspired after normal breathing. This was normal breathing, but even additional amount of air was inspired. Okay, and here the additional amount of air is expired. What's happening here? Here the additional amount of air is expired. So what's happening? This additional amount of air which is expired is called as expiratory reserve volume. This is expiratory reserve volume. This is called expiratory reserve volume. So this is ERV or expiratory reserve volume. And what is the value of this ERV here? What is the value of this ERV here? If you can see, it is 15. 30 minus 15 is 15. The ERV is 15. I will draw this line here again. Okay, so that you should not get confused. Okay, so this value is 15. So what is the value? 15 into, this is 15 ml per kg. So for 70 kg it will be 15 into 70. That comes around 1000 liter or 1 liter. Okay, 15 into 70, that is coming around 1 liter. So it is about 1 liter. The value is about 1 liter. Actually it is 1100. It is rough values. So it is 1 liter. 1 liter. Fine. It is 1100. 1 liter to 1100. But I am writing here 1 liter. We are calculating in ml per kg. Okay. Now, there is some breathing process going on. We are inhaling, we are exhaling. Somewhere we are additionally exhaling, inhaling called inspiratory reserve volume. Somewhere we are additionally exhaling, that we are calling expiratory reserve volume. Now there is some volume in the lung which is not taking part in this respiration. Why? The lungs can never be emptied. Even if someone is dead, lungs can never be emptied. There is some volume of air which is not taking actively part in this. It is residual volume. Even after full expiration, there is some volume of air remaining in the lung, that is called residual volume, and this is that volume. This is what? Residual volume or RV, and this is what? Residual volume, which we call RV. And what is the value for this? 0 to 15 means up to 15. It is about 32, not 30. Actually, sorry, this is my mistake. This is 32. So the difference in expiratory reserve volume was what? 15 to 17. It was 17. So it is around 1100 to 1200. It comes around 1200 ml actually. It comes around 1200. 17 into 70. 17 into 70. That will be around 700, 500 and 700, 1200. It will be around 1200. It will be around 1200 ml. Fine. It is fine. 32. Then this value is 0 to 15. This value is in ml per kg. So 15 ml per kg. So 15 into 70. This is 1 liter. This is around 1 liter. Are you getting this? So 15 into 70, that is around 1 liter, or you can say 1100 ml. Actually it comes around 1.5 liter. So it is 1100 ml. Calculations can be somewhat different, but the exact values are not needed. This is the nearby values. Okay. So this is what residual volume. So this is what residual volume is. This volume is not taking part in this respiration. Is it taking part in the respiration? No. This is there even after full expiration. The some volume of air is still remaining in the lung, that is not expired. So that is called that is not expelled, that is called residual volume. And the residual volume is what? 0 to 15 ml per kg. So for per kg it is 15 ml. So for 70 kg it comes around 1100 ml. Fine. Now this is what about volumes is there. Now let's go to capacities. In the beginning I told you that volumes can be measured. They are measurable. Okay. Say tidal volume is about 500 ml. 500 ml. Fine. Say expiratory reserve volume. Expiratory reserve volume is what? This is around, expiratory reserve volume is 1200 ml. Fine. This is 500 ml. I'll write here. This is about 500 ml. For 70 kg adult, 500 ml. This come expiratory reserve volume of 1200 ml. This is 1200 ml. Fine. And inspiratory, that is additional inspiration even after inspiring normally, that gives 3 liter. That is around 3 liter. Fine. So these are what? Well, volumes that can be measured. Even residual volume. Residual volume has value of 1100 ml for 70 kg adult. For 70 kg adult. Okay. Now let's go to some capacities. Fine. See, the tidal volume that is getting inspired and the additional volume that is getting inspired means tidal volume Vt plus IRV, that is inspiratory reserve volume. These two volumes combinedly called as which capacity? This is inspiratory capacity. This is called inspiratory capacity. Means this much is the capacity to inspire, a normal inspiration and additional inspiration to full of your strength, called inspiratory capacity. Now then this is what? End reserve volume, expiratory reserve volume. This will, the normal, this is what? Inspiratory capacity. I'll just give full stop here. Then this expiratory reserve volume plus this reserve volume, this both are what? These are the volume which can be expired, which can be expelled, but this volume is not taking part in the normal expiration, but this volume is there. Okay, this volume is there. So this volume can be exactly, theoretically speaking, this volume can be expelled. So this volume functional residual capacity, FRC. This is called functional residual capacity. That means a volume functionally is there which can be used in expiration. Speaking theoretically, because the residual volume is not taking part in actual inspiration and expiration. Is it clear? Now just come here. Now the volumes that can take exactly part in the what? That can take part in breathing, that is functional volume. What are the volume that can take part in breathing? This is always normal. Even we can inspire additional, even we can expire additional. Okay, like this. So additional expiration, that means ERV, expiratory residual volume. Additional inspiration, that is IRV, inspiratory residual volume, inspiratory reserve volume, expiratory reserve volume, as well as tidal volume. All three are taking part in what? All three are taking part in normal respiration. They can be utilized in respiration. They are functional. That's why they are vital and important. Because when I need to expire extra, I should be able to. When I need to inspire extra, I should be able to. Means they are maintaining vitality. They are vital. They are important. So they are called vital capacities. So we saw inspiratory capacity is what? Inspiratory capacity is IRV, inspiratory reserve volume, plus Vt. It is IRV plus Vt. Is it clear? This much we can inspire. Then we saw FRC, functional reserve capacity. Okay, functional reserve capacity is what? ERV, expiratory reserve volume, as well as residual volume, because this much we can expire. Okay? So this is also called as expiratory reserve capacity. A functional reserve capacity. This is capacity. Okay, expiratory reserve volume and FRC, functional reserve capacity. So this much is that. Okay, including this. That means ERV, plus RV. Fine. Then we came to vital capacity. Vital capacity is all the volumes that are actually taking part in normal respiration, normal as well as additional respiration, additional inspiration, additional expiration. Residual can never take part, so residual is not considered here. It is vital capacity. Now comes to total lung capacity. Let's come to total lung capacity. What is total lung capacity? Here it is what? RV. If you see this here, it is RV. RV plus vital capacity. RV plus vital capacity is TLC. Total lung capacity. This VC plus RV. Or you can split this VC into what? IC plus FRC. Sorry, not FRC. IC. You can split this VC into this VC. Vital capacity is what? The complete capacity, that is ERV. This VC is what? IC plus ERV. Okay. Expiratory reserve volume. So this vital capacity will be like this, up to this. So this is expiratory reserve volume is added in it, as well as tidal volume is added in it. Isn't it like step here? The first step, the total lung capacity. Then we leave one step. If we are going one step ahead, that means one step minus. That means reserve volume minus, that is vital capacity. Fine. That means reserve volume is not taking part, that is one step minus. Then we are getting another step where we are getting inspiratory capacity. That means there is no reserve volume as well as there is no expiratory, there is no residual volume as well as there is no expiratory reserve volume. That is functional residual capacity is not there. So this is like step. If someone is climbing here, say this person wants to climb this. At first step he will get TLC, total lung capacity. Okay, then he will try that I should be able to try for TLC, but residual, he finds that residual volume can never be added, so he will get here. Then that person will jump here when he will find the inspiratory capacity at the top of all. Fine. So in this way the lung capacities are measured from these lung volumes. Is it clear now? So these are different lung volumes and these are lung capacities, which are addition of these volumes. Fine. Now what is minute volume? One term is used sometimes which we call minute volume. Minute volume. You know what is respiratory rate? It is 12 to 16 beats, 12 to 16 breaths per minute. Is a breath, not beats. 12 to 16 breath per minute. This is normal respiratory rate, and these volumes we are calculating in what? In one breath. These are the volume in one breath. These are volume in one breath. If these are the volume in one breath, then how many will be the volume in 1 minute? I will have to divide the respiratory rate by the value. For example, if I take tidal volume for 1 minute, complete respiratory event for 1 minute, that is 12 to 16. If it is 12, then Vt into 12, that will be 500 ml is for 1 breath, and for 12 breath it will be around 6 liter. So for 12 breaths, that is this per minute, the number of breaths per minute to be multiplied by the corresponding volumes. If I multiply inspiratory reserve volume, that is 3 liter inspiratory reserve volume, with the number of breaths, then what will the value? The number of breaths are 12 and the inspiratory reserve volume is 3 liter, that is 3000 ml into 12, that will be around, that will go to 36,000 ml. That will go to 36,000 ml. That is 36 liter. Fine. So in this way you can calculate this volume for particular minute, and these are called minute volume. A tidal volume multiplied by breath rate. If it is 12 into 12, it is 14 into 14. This is for 1 breath multiplied by number of breaths. It's called minute volume. Then what is the significance? Initially I told you the significance of this volume and capacity is what? It indicates normal pulmonary function, if it is normal or not, or it is diseased. In diseases like obstructive pulmonary diseases, where patient cannot exhale, where patient fails to exhale, okay, that diseases are called obstructive diseases. Restricted pulmonary diseases, where patient cannot inhale. There are some gaseous exchange diseases. Gaseous exchange diseases means when alveoli is edematous or alveolar membrane is damaged, or some antibodies are there, some autoimmune diseases are there which are damaging, hampering basement membrane of alveoli, filtration membrane, capillary endothelial cells, means all the part that is in alveoli or the capillary lining the coming in closure with the alveoli. So the gaseous exchange in the alveoli cannot take part efficiently. So the diseases of that part are called gaseous exchange diseases. So there these volumes can be hampered. Then there will be there are diseases like pressure diseases. We discuss pressure diseases like disease of diaphragm, disease of muscles, myopathies, disease of ribs, okay, and then disease of nervous system, neurons that are supplying nerves to muscles. So ultimately they are not letting chest wall to expand and to compress. So that means there is problem in respiratory mechanism of nervous system, or local physiology, local pathology of muscles or ribs or diaphragm. So in this way, the problem, whether it is obstructive, whether it is restrictive, whether it is pressure related diseases, mechanical, or whether it is gaseous exchange diseases, can be understood from the volumes. These volumes are important. That's why spirometry or pulmonary function test is done, to get idea about the volumes. If the volumes are not good, in case inspiratory reserve volume is not that good for 70 kg adult, inspiratory reserve volume is not that good. It should be 3 liter. If it is say 1 liter, that is 1/3 of the normal value. That means he has what? He is unable to inspire a lot. Extra inspiration is something which is difficult for him. So extra additional inspiration is difficult, means difficulty in inspiration is restrictive lung disease. Okay, or he is not able to reach to the this expiratory reserve volume, which is around 1200 ml. Say he is expiring additional only 200 ml, like not he's not expiring a lot. So that time he has what? Obstructive lung diseases. Fine. So this is all about lung capacities and lung volume. Let's meet with the next lecture soon. Thank you very much.